Hello kids, nice to have you back and learning. What we're going to do this week is we're going to talk about exponential functions, growth and decay. Today's going to be the first day. We're going to have little lessons and then little homework. So you only spend about 30 minutes a day on math. We will have quizzes. So you need to be learning this, especially for next year. Your next class will expect you to have seen this and not like master it, but you will need to know how to do this. So let's start with evaluate the expression. Anytime we work with an exponential has a variable as an exponent. So like right here, we have our variable there. So this is a exponential expression. And what we're going to be doing is we're going to be putting these values in. We're going to start with A, x being 4, and then B, x being -3. So for A, we're going to have 3 minus 5. And my x value is 4, so I'm going to put a 4 up here. And so now we use the order of operations, which is going to give us 3 minus 625. And then what is 3 minus 625? It's -622 as our answer. Not too bad. So now we're going to go on to B. B has x being a -3. So we write it in 3 minus 5 to the -3 power. Uh-oh, can we ever have negative exponents? The answer is, oh no. So what do we do when we have negative exponents? We take it to the denominator. When we take it to the denominator, the exponent becomes positive. So it's 3 minus 1 over 5 to the 3rd power, which gives us 3 minus 1 over 3 to the 5th power is 125, which is all good there, except now we have a whole number minus a fraction, so we know we have to make them common denominators. So if I put the 3 over 1, I know that I'm going to have a common denominator, and that common denominator is 125. So what do I have to multiply the 3 by? I have to multiply 3 times 125. 3 times 125 is 375. So now I have 375 over 125. Minus 1 over 125, which gives us a total of 374 over 125 as our answer. All right, good. Let's do the next one. For the next one, we're going to put in A, x equaling 4. So 5 times 2 to the 4th. Here's one mistake that a lot of students make is they multiply the 5 times the 2 and then take it to the 4th power, but you can't do that. You got to remember the order of operations, so I have to use my exponent first. So that's going to be 5 times 2 to the 4th power is 16. 5 times 16 gives me 80. So my answer for A is 80. When we go to B, I'm going to plug in my -3 for my exponent. So I have 5 times 2 to the -3rd. Uh-oh, negative exponent again. We know we have to take that to the denominator. So we have 5 times 1 over 2 to the +3. Once it changes levels, that negative goes away and it becomes positive, which gives me 5 times 1 over 8. That's 5 over 1 times 1 over 8. And my answer turns out, when you multiply straight across, 5/8. All right, we have one more here. Let's see how we do with this one. For A, we're replacing the x with a 4. So 3 to the 4 minus 4. 3 to the 4th power is 81 minus 4. 81 minus 4 gives us 77. Not too bad. And then part B. We're putting in x as -3, so 3 to the -3rd minus 4. Uh-oh, negative exponent. Take it to the denominator. 1 over 3 to the 3rd minus 4. That's 1 over 27 minus 4. Here again, we have a fraction and a whole number. So I'm going to put this over 1. And we're going to have to multiply the top and the bottom by the common denominator, which is going to be 27. So that's going to give us 1 over 27 minus 108 over 27. And our answer is going to be -107 over 27. Okay, so part of your lesson or your homework tonight will be replacing your exponents with these values. Going on. We're looking at the graph of exponential functions. The first one is exponential growth. As the x increases, the y increases. So this blue line right here is going to be our exponential growth. It starts out not going very high very quickly, and then all of a sudden it takes off, going straight up. The exponential decay, as x increases, the y decreases. So it's going to start high and end low. And what you see right here is an asymptote. There's an asymptote at y equals 0. That means it's going to get very, very, very close to the x-axis, but it's never actually going to touch it. And when we look at all this together, we get this equation where the a value is the initial amount, so that's what you start with. The b value is your rate of increase or decrease. So as it grows, my b value is greater than 1. If it is decreasing at exponential decay, my b value is going to be between 0 and 1. So it's going to be a decimal between 0 and 1. So let's look at this next problem. All right, we have to tell whether the function grows or decays. So don't forget, we have y equals a b to the x. The only value that matters on growth or decay is that b value. I do not need the a value at all. So looking at this one, this is my a, this is my b. My b value is 4. 4 is greater than 1, so this would be a growth. On our next one, 10 and 5/8. My 10 is my a, 5/8 is my b. Now 5/8 is between 0 and 1, so this is going to be a decay. The next one, you look at it for a second and then we'll do it. What's your a? What's your b? Your a is the 1/3. Your b is the 3/2. I don't care what that A is. 3/2 is greater than 1, so this will be a growth. And then our last one, a lot of you just look at it and you say, ooh, 7, 7's bigger than 1, so it's a growth, but we made it tricky. Tricky, tricky, tricky. Look at that negative. We talked about what we did with negative exponents. That means whatever number this is has to go to the denominator. So I can rewrite this as f of x equals 2 times 1/7 to the positive x. As long as that 7 goes to the denominator, then my x value becomes positive. It just takes the reciprocal of it. So now we're looking at the 1/7 as my b value. So 0 is less than 1/7, which is less than 1. So this is actually a decay. Watch the tricky problem with that negative exponent. All right. Now, use the graph to identify the value of the base. Okay, so what we're going to do is we're going to make an XY chart. And I'm going to write in some of the values that we know. Well, right here, we know 0 and 1, which means b to the 0 should equal 1. Yep, that is true. Next number we know, our point, is 1, 4, which means b to the first equals 4. Well, what to the first power equals 4? B does. So b is going to equal 4. So our equation is going to turn out to be f of x equals 4 to the x. Good. Hope I'm not going too fast. All right, we just have 2 more problems and we're done for the day. 2 more. All right, here is the function that we are going to be graphing. To graph this, I like to make an XY chart. And we're just going to put in some values. I'm going to put in -1, 0, 1, 2. And we can start off by asking, is this a growth or a decay? Well, what number has the exponent? The 3. Since 3 is greater than 1, this is going to be a growth graph. Growth. That's an O. Okay. So if I plug in -1, 3 to the -1 has to go to the denominator, so my answer is going to be 1/3. So -1, and we're just going to estimate there. 3 to the 0, anything to the 0 power is 1. So my next point is going to be 0, 1. Next I have 3 to the first power gives me 3. So my third point is going to be 1, 3. And then last but not least, 3 to the second point, 3 to the second, is 9. So my fourth point is 2, 9. Okay, and then we are going to connect the dots, and this is the exponential value, exponential graph. And don't forget, what does it sit on? Here's its asymptote at y equals 0, which means it's not going to touch or cross that line. So if we look at this, what can our domain be? Can I put in -15 for x? Yes, it's going to be an ugly number, but yes. Can I put in 100 for x? Yes, that's going to be a big number. So my domain, I can go to the left forever. I can go to the right forever. So it's going to be negative infinity to infinity. Just gets very, 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 very close to that line. The range, it's starting here and then going up. Does it ever hit 0? No. So that means it's going to be a parenthesis. And then it's going to go up forever. So it's going to go to infinity. What is the y-intercept? Well, we found that when we did our table, our y-intercept is going to be 0, 1. And you need to write it as a point. Does it have an x-intercept? Well, will it ever cross the x-axis? No. So you put none. We do not have any points that are going to hit that x-axis. And our asymptote we already talked about is y equals 0. And here comes our last problem. And this one kind of relates about what we're going through. So in this time in our country, we're trying to flatten that curve. So what does that really mean? So I made up a problem. Imagine 3 people went overseas and came back with the COVID virus. Each of those people give the virus to 4 people on the first day. Each of those 4 people give it to 4 more people on the second day, and this trend continues. How would we write the equation? So we know it is y equals ab to the x. And a stands for our initial value. So the initial number of people was 3 in this problem. So y equals 3. And then what is happening every day? They talk to 4 people. Those 4 people talk to 4 more people. And on and on and on and on. So my b value is going to be 4 to the x value. So this right here is our equation. Now the last statement says, how many people would be infected on the 5th day? That means our x value equals 5. And we're going to plug that in. So y equals 3 times 4 to the 5th power. Don't forget, you cannot multiply that 3 times that 4 first. You have to take 4 to the 5th power first. So y equals 3 times 1024. So y equals 3,072 people. So when they mean flatten the curve, they want the amount of people, your b value, to decrease. So you're staying inside, so you're not talking to people on the outside, so there's no way that they could get infected. All right, so your assignment for today is on big ideas, 6.1a. You will be turning in all your homework on big ideas. You will be taking quizzes / tests on big ideas. So you need to get back used to that. I will be having office hours. I'll put it on Canvas when those office hours are going to be. And I'm hoping to use Zoom for one of them so I can see your little smiley faces getting back to work. Bye.